This is rotational motion. Build up your understanding. Question 24 from the book Pathfinder. So let us see what is the question. Question is there's a metal pipe. It is bent at right angle at midpoint. So this is equal to this, and this is the hinge. Now it can rotate freely. So if this is hinge, it can rotate freely in its plane. And then there's a flexible hose pipe is connected at the pivot end. So here you can see this is the pipe. When water is fed at a particular rate into the pipe, the upper arm of the pipe, they're talking about this one, makes an angle alpha with the vertical, right? So that we can see this angle is alpha. Now, if rate of feeding water is gradually increased n times, eta times, then we have to find an expression for beta, which the upper arm of the pipe will make with the vertical in terms of given parameters. So let us see how do we solve this. See, conceptually, it is a simple question. You can write equations, you can write an expression which relates beta and alpha, right? But then when you match the answer given at the back of the book, then it requires some amount of thinking and to give the answer in that particular format. So let us see. So initially, if there is no water supply, right? So there is no hose pipe, there is no water supply, then what will happen? Center of mass will be exactly here, right? So that torque of mg becomes 0 about the hinge point. So center of mass is here. This point is x1 by 1. I've written the coordinates. This is midpoint of this. And this point is midpoint of this. So and now I am applying the condition that center of mass should be along this line. This is what is going to happen if there is no additional force. There is no force due to the action of water. Then I am finding theta. So how do we find theta? Simple, m1 x1 plus m2 x2 equal to 0 if this is the origin. I'm taking center of mass as the origin. Now x1, what is x1? X1 is this thing, right? X1 is this distance. See here, let me mark that also. So this is x1 and this is x2. So x2 is this one. These are the x coordinate of the center of mass of this object and x coordinate of center of mass of this object. X1 is negative, x2 is positive. So what is x1? See here, this is L by 2, this is theta. So this is x1. X1 is L by 2 sine theta. L by 2 sine theta, but it is negative. So I put here negative sign. And then here, now we have to find this distance, right? So let us see how do we find this angle is theta. You can see complete the right angle triangle. Now to find out this, the one x2, what we can do, we can then we can complete this, right? So this will be this length, which the line which I have drawn just now, this is equal to what? L by 2 cos theta, right? So L by 2 cos theta, that is what I've written, but I have to subtract this distance again. This distance is how much? L sine theta. So L sine theta, this is equal to 0. So I have to write here 0. So when this is equal to 0, you get a little bit of simplification and you get tan theta equal to 1 by 3. So what is tan inverse 1 by 3 angle? This angle is when there is no water reaction, there is no water. Simply, if there is this structure and if it is free to rotate, then the angle theta made by this structure with the vertical is tan theta equal to 1 by 3, right? So that is what it is. Now let us see what happens if some amount of water enters from here and leaves from here. So when it is leaving from here, there is a reaction force V dm by dt, right? So I have not given proof of that. I hope you know that V dm by dt will be equal to rho a v square, that we know, that we have studied in fluids. So this is the reaction force. Now, of course, due to this reaction, this angle is going to increase. Initially it was theta, now it will increase. So new angle becomes alpha, that is given in the question. Now the fact is, the point is that this line, if you assume that this is the line which is passing through the center of mass, right? Then here, if you draw that line at an angle of theta, then center of mass is again at this line. So let me say this again. So this is the one rod. So from this one rod, if you travel angle theta in this direction, anti-clockwise direction, then there's a line, right? Center of mass lies on that line. This does not change. So center of mass is still lying on this line. Do you understand? This angle is theta. Fine. So same figure I have drawn. So it makes this angle, remaining angle, as alpha minus theta. Now what's going to happen? Now about O in equilibrium, about O net torque has to be 0. So whatever hinge reactions are there about O, those will not provide any torque. So torque of gravity should be balanced by the torque of this reaction force rho a v square, about the hinge point. So what is the torque of rho a v square about the hinge point? This is 90-degree angle. So it's very simple, force and perpendicular distance. So it is rho a v square into L. Is that understood? Now after that, see, this is this line and this is C, this is OC length. And then about this axis, when we are finding torque, gravity is still acting here. So this is the mg mass. So if this is mg force, then this distance we are looking for, perpendicular distance, right? That distance, if it is OC, then this distance will be OC sine alpha minus theta. So this is OC sine alpha minus theta. That is equation number 1, right? So we are almost not done conceptually. So if you increase the water flow by eta times, since it is proportional to V square, the force will increase by eta square. So force increases by eta square because density is constant, area is constant, velocity becomes eta times, so reaction force will become eta square times. Now imagine that if this angle is beta, because when this becomes eta times, given is this angle becomes beta, this angle still remains theta, right? So the line from here, this line, center of mass line will still be at angle theta. So what will be this equation? Same equation. This is nu, right? Nu v becomes eta v. OC remains OC only because that is the distance of this point and this point of the structure. And new angle is beta, so sine beta minus theta. That's it. So from these two equations, we will get the answer in the format given in the book. So from 1 and 2, if you see, so rho a v square L is this, eta square is left. So I'm from these two, I have written this. After that, beta minus theta is sine inverse eta square sine alpha minus theta. Remember, theta is this. So beta is equal to theta plus this, and then theta I have substituted from here. So that is the answer. This is what is given in the book, right? So if you don't start solving from this approach, you can find out the relation still. You can find the relation between beta and alpha, but not in this form, right? So that is the whole point. So that's it. That was my analysis. If you have liked this analysis, please like this video and please subscribe to this channel also. Thank you very much. Thanks a lot for your time. All the best.